All right, hello. We are getting ready to start on three-step conversion webs. And as some of you have already noticed and asked about, you can't do a three-step problem with this web. This web is only equipped for one and two-step problems. That is because this is a simplified web. Okay? The actual conversion web that we're going to be using for most of the remainder of this class is this one here, which you've probably already noticed. Now, I have a bunch of green stuff written around it that I'm going to erase here in a bit to make it a little easier to read. The green is to indicate the units that we are talking about. So, you'll notice this is just a mirror. Okay, the bottom of this, these three here, are exactly like that one that we had to begin with. Items, moles, and mass. And mirrored above it is a reflection of the same thing. Items, moles, and mass. Okay? Now, from there, the connection between the two is this new thing, the molar ratio. That molar ratio is what actually connects these two. Now I'm going to pause this, mute my phone so it doesn't go off again, and erase all of the units that are kind of distractors right now so that you can see this just a little bit more clearly. Okay, so now that all the units are gone, this is hopefully a little easier to read. Now, you might have noticed on the first view that something else has been added to each of these on the bottom, and that is the word known. Now, one of the things I ask you guys every time we do one of these problems is, what is your known? And then I ask you, what is your unknown? Now, known and unknown in a three-step problem are sometimes not going to be the same compound. And so you have a compound that's going to be specifically asked about and a compound about which you are given some information. The one that you're given information about, that is your known. The one that you don't know anything about is your unknown, which is what UNK stands for up here at the top. So down here, if you're given the mass of something, you're starting here with the mass of your known. Okay, if you're given the number of molecules, you're starting with the number of molecules or items of your known. And if you're given moles, you start with moles of your known. You're going to be starting at one of these three locations. And then your unknown, a different molecule, is going to be up here across this new bridge. If you're given the number of moles and asked about the mass, then you're going from here to here, the mass of your unknown. If you're given the number of moles and asked about how many molecules, you're going to items of unknown. And the bridge that connects these two reflections is this new blue factor called the molar ratio. Now, the rule of thumb that I always use is that you write your molar ratio as the known over the unknown. And what I'm going to do next is actually show you how to determine the molar ratio, but you have to have, in order to get your balanced reaction, I'm getting ahead of myself there, in order to get your molar ratio, you have to have a complete balanced chemical equation. And so I'm going to walk off screen again, pause it, and this time I'm going to put some actual equations on the board with some practice problems on this so that you can take a look at those. So, yeah, let's do that. All right, here are 4 practice problems, and each one has a given equation which is already balanced. The balanced part is important, so these are balanced. Okay, so let's look at, well, first let's do this. So the molar ratio is equation specific. It is unique for every equation. Much like the molar mass is unique for every compound, every equation, specifically every pair of components in an equation, is going to have a unique molar mass, a unique molar ratio that you're going to have to figure out. Now, it's not complicated. It's very easy, and I'm going to go through and show you how to get that. So, if we consider this reaction here, where copper is one component, oxygen is our second component, and copper 2 oxide is our third component. Each one of these has a number in front of it when it's balanced. In the case of the oxide, it is an implied, but not actually written down, 1. Because we don't usually write those ones. When we were going through and doing balancing, I had to make you write the 1s, because otherwise you could just leave everything blank and I had to give you points for when it wasn't there. So I made you write the 1s. But most of the time you don't actually see these 1s in a balanced reaction. They're just implied, much like subscript 1s. We just don't write them. Now what this is asking for is the molar ratio for copper metal to copper 2 oxide. So to get that molar ratio, we need the balanced reaction, which we have here. Copper metal, oxygen gas, copper 2 oxide. It wants copper metal first. So copper metal is the first one here. This is going to be 2 moles of copper. The 2 is the coefficient. Copper is the formula of what was asked for. And it's called the molar ratio because it's the number of moles. Okay, this is telling us if I react with these coefficients, remember what they mean. If I react 2 moles of copper metal with 1 mole of oxygen gas, I will produce 2 moles of copper oxide. That's what this reaction actually means. So the molar ratio for copper metal to copper 2 oxide is going to be 2 moles of copper over 2 moles of copper 2 oxide, CuO. That's the molar ratio. That's it. That's all there is to it. You add the word moles between the number and the formula, and that's the molar ratio. That's all you have to do. So I'm going to step off screen. I want you guys to do the other 3 here. I'm pointing like it's this way. This one, and this one. Pause this, figure out these, and then I will unpause it, and I will put the correct answers up so that you can check. So do that now. All right, and hopefully you got these worked out. So for the first one here, for B, it asks for the molar ratio of H2O to O2. So H2O is going to be 2, because it's a 2 here, moles of H2O. Then O2 on the bottom, there is no coefficient, so this is a 1, so 1 mole of O2. For C, we're after iron metal to hydrogen gas. Iron metal has a 3, hydrogen gas has a 4, so 3 moles Fe to 4 moles of hydrogen gas. And then down here, HCl to AsCl3. HCl is a 6, AsCl3 is a 2, so 6 moles of hydrochloric acid to 2 moles of arsenic trichloride. And that's really all there is to molar ratio. Now, in the problems that we're going to work, they're not going to be labeled quite this nicely. You have to do the known over the unknown, which means you have to first identify your known and your unknown. And that is what we're going to actually work out in the next video, since this one's getting kind of close to 10, and I'm worried the next one might hit 30. I'm going to end this video here with the molar ratio, and our next video, I'm going to assume you have already seen this one and just dive right in to solving a 3-step conversion web problem using the web, not this one, the longer one, which I will put on the board before that. So I hope this helped out, and I will see y'all eventually.